NASA Carbon Cycle and Ecosystems Office, which is helping with ABoVE and the ABoVE Science Cloud. And on the line, we also have a number of our collaborators on the Science Cloud. A few of them are going to be presenting today. So we have Ben Bledsoe, who's working on Windows issues with the Science Cloud, and also Scott Sino, who's a sysadmin and does a lot of work on the Science Cloud. And they're both from the NASA Center for Climate Simulations. And we also have Jim Shute. I see he is now joined as well, so let me add him up here as a presenter. And Jim Shute is also going to be presenting a little bit. He's working on the Esri architecture for the ABoVE Science Cloud, and so he'll be talking a little bit later as well. So we will go ahead and get started. I'm so glad all of you could join us. I know we had some trouble last month with our webinar line, and I'm glad we've gotten that worked out and that everyone is on the line today. And so we're going to present today what we had planned to present last month. And the Science Cloud team at NCCS has been doing quite a lot of work over the summer. We haven't met since the summer. And so they're going to share some of that work with you, and we'll talk a little bit about some future plans, and we'll give a little demo or two, and then we'll have a time for question and answer. So we hope that you have questions and think about them. If you have whatever kinds of questions you have about, you can ask us about getting onto the Science Cloud or how to use the computing resources, and we can help answer them. And if we can't, we can always go find the answer. We really want this to be a platform that you as scientists of ABoVE can utilize, and we know it's getting close to AGU, and people always have a lot of projects they want to do before AGUs. We really want people to start using it, and we don't want everyone to try to use it all at once at a couple weeks right before AGU. So if you've got a project you think you're going to want to use some Science Cloud resources for, start really thinking about it now and trying to get on there and use it, and we can help you get set up. All right. So I mentioned our speakers already. We'll start off first with Ben Bledsoe, who's going to give a little bit of an intro about the changes we've had to the Windows systems on the ABoVE Science Cloud. And then we'll talk a little bit about some of the digital globe data and how it's now positioned on the Science Cloud. And then we'll talk a little bit about ArcGIS implementation on the Science Cloud. So we'll let Ben go ahead and start it. And Ben, you are a presenter now. I've got the slides up, and you can go ahead and talk for a bit.
Great. Can you hear me all right?
Yes, I can hear you.
Okay, great. I'm having a little problem on my end, but I guess my name is Ben Bledsoe. I'm a sysadmin at Goddard. We've had a lot of changes, I guess, since we first got started with the Windows domain. I guess just from the top bullet, we are now in the ADC domain. So for any of those users who were with us when we were using the adapt domain, if you have not been logged in a while, that is no longer valid. It no longer works. And you will have to use the ADC domain. And with that comes a new temp password. So if you were with us from the beginning and you haven't contacted me in a while, please do so, or you can find your temp password in your home directory in a text file. We are happy to announce that Guacamole is a much easier means of accessing your Windows VM, and that'll allow you to hop on any web browser, Chrome, Firefox, Explorer. I haven't tested Safari, but I don't see any reason why it wouldn't work in Safari. So any web browser really, on any system, just go to the guac.nccs.nasa.gov, you sign in, and you can access your VM through there. A lot of you have not yet received your actual virtual machine host names yet, so you might be a little confused of where do I go to log in. I guess for anyone who is in dire need of logging in, please contact me. Don't hesitate to contact me. We're trying to get as many people on our system as possible. But at the same time, if you're thinking about trying to get on and you don't know when you'll be using systems, contact me. Let me know. We'll try to get you on when you need it. But again, we're just trying to get as many people on as possible. Other than that, were we thinking of showing a guacamole
Yeah, I'm going to do a quick demo.
demo?
Yeah, I'll go ahead and
Okay,
do that.
sure.
So a few things I wanted to mention about the Windows machines. One is if you think you're going to use a Windows machine and you don't have a login on a Windows machine, contact Ben and his email is there. Or you actually, probably the best way to do it is send an NCCS support ticket to support@nccs.nasa.gov so they can keep track of how many requests are coming in and we can get you a Windows login. And if you're not sure about your Windows login, you can always contact Ben or support to get your login information. And I'm going to give a quick demo of Guacamole. I think we'll wait until after Scott talks a little bit about some of the NGA data, because our demo will actually be a demo of how to access NGA data on the Windows system. So it's kind of combining both things. But stay tuned for that. And with that, we'll go ahead and we'll let Scott talk a little bit about some of the work that's happened with our digital globe data on the Science Cloud?
Indeed. So we've historically stored the NGA data under the Gluster file system implementation. That was a clear source of performance limitations as we grew the archive to size. So we've recently completed transferring all of that data into GPFS, which is a much more industrial strength network file system. And that was completed earlier this week. Julian is in the process of conglomerating that collection of data with new data we've ingested directly into GPFS over the course of this calendar year. Once that's completed, we'll have a single presentation layer for all the GPFS data that's entirely backed by GPFS, that's entirely backed by that file system, and that has proven to be a much more expedient means of data access, particularly under Windows platforms where we were forced to utilize NFSB3 for that data access. It was unmounted. The NGA data, as you may well know, was unmounted from our login nodes as a matter of revamping our policy for NGA access and trying to better control dissemination of NGA outside of the ADOP environment. We're not outright prohibiting it, but we are in the process of devising modified procedures for permitting users to pull that data outside of that.
Yeah, let me go ahead and jump in there too. So I had hoped to have our new policies in place by today to be able to talk with you all about them on this webinar. We're still waiting for our final approval, but we are working to kind of segment the imagery into different zones. So above would be kind of an Alaska and Canada zone, and then you would get access to the zones of data that you need. And if you need to copy imagery out of the cloud, we have kind of a form, and you need to write up a little justification as to why you need to copy that imagery out of the cloud and where you're going to use it and how you're going to use it. And that's just some for accounting purposes on our side. We are, this is kind of our reminder on the use agreement. We are bound by the NextView license, which the National Geospatial Intelligence Agency has entered into with Digital Globe to access this imagery. And for ABoVE users, you are only allowed to use this imagery for an ABoVE research project that is directly contributing to NASA and the NASA-funded ABoVE project. So if you wanted to use this imagery for something else, you would actually have to go to Digital Globe and purchase that license from them to use it for a different project. But we have it available for your NASA-funded ABoVE project. So that's my note on the use agreement, and I want to share my screen for a minute. I was going to put something else on here. Let's see. So up on our website, you all have seen this page, the Science Cloud Setup and Access page. And about halfway through the page, we have these NGA files that you've all looked at, hopefully, before you've signed your form for the NASA NGA data agreement. And one of those files is the briefing on proper use of NextView licensed digital globe imagery. And in there, I'm just going to remind you about one of these pages. And that is here. So any digital globe imagery or imagery derived products must contain the copyright and NextView license notice. And you'll see that here over on the, hope you guys can see my mouse. Here on the right-hand side of the screen, we have this imagery example. So we've got the imagery of the Barrow shoreline. And right there in the image, it says copyright 2015 digital globe NextView license. So anytime you use the imagery, it should appear within the image where you got that imagery and what the license is and the year and the little copyright sign. And that would be the same for any imagery, as well as any imagery-derived product, such as an image-based map or a reduced resolution image. Anytime you have anything that looks like imagery, it should have this note on it. And then for derived products, you don't need to have it on there, but you should attribute the initial imagery use to digital globe. You know, if you created a digital elevation model, you should say this elevation model was made using digital globe data. Let's see. Can this go forward? There we go. So an imagery-derived product, again, here right within the imagery, this is an example of a fire perimeter and over top of some imagery. You should say 2015 digital imagery, NextView license with the little copyright sign. And then an example of a DEM down the bottom. You should write something about how it was used with digital globe imagery. So hopefully very soon we will have a little bit more information about that, and there will probably be a new form that everyone will be required to sign. I'm sorry about that, but it's a way we need to do that so that we maintain this imagery in a careful manner so that we can continue to access this imagery. You know, it's still very new, the sharing of this imagery with people outside of the intelligence community. So we want to make sure we can maintain our access. And this NextView license goes through 2020, so we've got a couple more years of really great collections of imagery that will be available to us. And then in 2020, the whole contract is renegotiated. So you know, we don't know what will happen there, but at least we've got a couple years of great imagery. So we need to make sure we maintain our use properly. So that's our note on that. And Scott, did you have anything else you wanted to say about the digital globe imagery?
No, I believe that concludes my two bits in there. The collection is up to 2.1 petabytes now altogether, and still growing. So we have a lot.
We have a lot, and you know, an issue with that is how do you view it? How can you actually view this huge collection of imagery? And so one of the things we've done to make it a little bit easier to view it is we switched it from Gluster to GPFS, which is a faster system, so you can more quickly open images and navigate to images. So that's one change that we've made. We're also still in the process of developing some imagery mosaics so that you can kind of pan around like you would on the web, pan around over top of the imagery. And we've demoed that a little bit in the past. We hope to have that operational early next year. And in the meantime, though, one way we found that's working well for people is to use this Guacamole Windows virtual machine through the Guacamole interface. So I'm going to do a little demo of that. Share my screen. Okay, so let's see. We will go to, okay. So what you're going to type in is HTTPS. Can everyone see my screen? Somebody give me a shout out, yes, so you can see it.
So Liz, I can see your screen.
Okay, great, thank you. All right, so you're going to go to HTTPS guac.nccs.nasa.gov, and it will take you to this wonderful NASA Access Launchpad page. And I'm not on the Goddard network right now, so this is what you would see even not being on the Goddard network. You would choose RSA token. All of you should have an RSA token. You put in your user ID plus your PIN and token code. So your PIN is the code that you set up when you got your token initially, plus whatever 6 digits are showing on your token code at that time. Okay. All right, so then you should get to this page called Guacamole, where you put in, again, this would be your username for the Science Cloud. It's probably this, I think it would be the same username that you use for NASA. Is that right, Ben? Or is it different sometimes? Might be different.
I'm sorry,
sometimes.
what'd you say?
This username that you put in here?
There's no domain. It's just eHoy.
Okay, and it will just be your username that you'd use for the Science Cloud.
That's correct.
Which for me is the same. And then here you're going to put in your, I can't do 2 things at once. Your password here is going to be the password you use to log into the Science Cloud. Okay, so that takes you to this page, which is the Windows virtual machine that is on the Science Cloud. And here you're going to sign into ADC. So you type in ADC with / and then your username again. And then here, this is going to be your Windows virtual machine password. So you will have to get your initial temporary one either from Ben, or he's put it, I believe, in your home space on the Science Cloud, or you can contact him to get that. So you put that password in. Then the first time you do it, you'll have to go in and change it. Okay, so then it'll open it up. And I was actually working on this earlier, so I could show you a demo more quickly. So you can see here I've got loaded in. I've opened ArcMap. Actually, one of the first things that you'll want to do is I'll just show you where you can find some of the imagery, so that you won't have trouble finding it later. So if you open up Arc Catalog and you look at this PC, you can see the different. These are the different volumes that have already been mounted to these Windows VMs. So your no backup space is here in G. Your home space, you can find it in H. The Landsat archive, if you want to look at that, is in L. And this NGA data, right now it's in P. Now that they've finished moving everything over to GPFS, they'll probably switch it around and then start it with N. But stay tuned for that. So then you can find all of the imagery in here. So that's where it's located. And then you can go ahead and add it right. You can open up ArcMap and add it right to your map. And I of course had already loaded this in just for the demonstration. But where it is, you'd go to the P / data. And you kind of have to navigate through here a little bit. So you'd want to go to data, and then if you want to just look at the footprints file, which is what we use to kind of see where the imagery is located, you've got to navigate through that index, footprints, current, and this one was done in September 20th. And there's a whole set of footprint files that have been added in here. So right now they are organized by sensor, so this is GUI, and then by processing level, so we have level 1B, 2A, and then we have the year. And so we will be updating this shortly as well, because right now we have certain things sectioned out by whether or not they were in the GPFS file system or the Gluster file system, but now that everything just this week was moved to GPFS, we'll probably be doing a new footprints file soon. So I navigated to the GPFS Worldview 2 Level 1B products for 2015, and you'd go ahead and add data. I've actually already added mine in here, so you can see it here on the map. And so this is just the WorldView 2 data that was collected for 2015 within the ABoVE Science Cloud region. And you can even add, this connects to the outside world. This isn't just within ADAPT, so you can actually add data from ArcGIS Online. So I added that ABoVE study domain shapefile just by searching for it within ArcGIS Online. So it's right here. You could add that in. I've already added it over here, so I won't add it again. And then you could navigate to, the study region you're most interested in. You could zoom in on that. I've selected a little region in the north of Alaska already just for effect. And let's see. I think it's thinking now. That's why I tried to do this earlier so it would have less to think about while I was doing this with you guys. But you could zoom into a region. There we go. Let's zoom out a little bit. I'm just gonna, there we go. All right. So much, this is just one sensor in 1 year, but there's still just so much imagery there. So you can, here, you know what we can do? We can, next time when it stops thinking, I'll have a better idea for it. But overall, this is a much faster way to get to the imagery than previously when it was in the cluster file system. I don't know why it's gotten upset with me right now. There we go. So why don't we just do this? Well, we'll just, I just want to zoom to the area that I wanted to show you guys. Okay. But when we have the imagery mosaics, probably around the spring of next year, it will be a lot easier for you to view the imagery, but this is one way to view it now. You could view this imagery with QGIS through the Linux VMs. However, that is difficult because it doesn't, QGIS doesn't open native files, and this imagery is stored as native files. So that makes it more complicated. You'd have to change the format for any image that you want to open. Okay, so there we go. So it's just such a large footprint file, I think, even though it's divided up into sensor. Because this footprint file is for the entire archive of digital globe imagery on the Science Cloud, not just the ABoVE section, but for all regions that are within the NASA kind of ADAPT system. And anyways, you could pick a scene, and I'll show you here with what it would look like. I've selected a few, and within a study area, and what you're going to go to when you open up the attribute table, you get so many different attributes: strip ID, scene ID. So you could also search by those if you already knew the catalog ID. If you had some idea of what you were looking for already, you can search by spectral type, multispectral or panchromatic, when it was acquired, the amount of cloud cover in the imagery. And then when you've narrowed down your search and you know what you're looking for, you can go all the way over to the S file path, which is here. And you can see where on ADAPT, or the ABoVE Science Cloud is one part of ADAPT. If you hear that, it's called the Advanced Data Analytics Platform. So if you ever hear ADAPT, that's what we're talking about, and the Science Cloud is part of that. You can navigate here to this file path, and I'll show you how to do that to find the imagery. So maybe this is because I have it opened in another session. Let me close this one out. Okay. So you can navigate down through here. So you go to, again, let's see, data, and then here we've got WorldView 2, 1B, 2015, and then this is organized by date, so Julian date here. And you can pick one of these images out. Let's pick this one here. We've got WorldView 2, 1B, 2015, 072, so date 072. and then you can pick one of these out. I'm not going to click on it now because I've already got it loaded in, but this little raster with a satellite on top of it, you can click on that and you just press add and it'll load in to your region, and so there we've got it loaded in. I think this one's in a slightly different location, so I'm going to have to zoom to it if it will. Let me turn this off. See if it'll let me zoom to it then. It always takes longer when you're doing the demo. Anyways, it's actually quite fast, and I don't know why ArcMap is giving me a hard time now. Maybe it's because I added in this above study domain from the web, but earlier today it was quite quick when I was doing this. Let's turn this off, see if that helps. I'd like to get to show you that. Well, maybe that'll start. There we go. Okay. Never quite right when you want to do it. I think this is more an ArcMap thing than the file system, because the file system is actually quite fast and easier to use. Might have to give this a couple minutes. Maybe we'll let Jim go ahead with his section of the presentation, and then we'll come back to this when it's. Oh wait, oh here it goes. Okay. I'm going to turn that off. There we go. So then you can get right into the imagery. It's actually quite fast. I think that was an issue maybe because I had the web service in there as well. I'm not quite sure, but earlier today I didn't have any trouble getting there. And then you can view the imagery right there in ArcMap on the Science Cloud from an internet browser anywhere that you want. And you can zoom all the way in and look at the detail of the imagery. And you can do this for whatever section of the Science Cloud where you have imagery stored on it. So it's a real great way to just view imagery if you're trying to look for field sites, or if you want to target which imagery you want to have, you want to download out of the Science Cloud if you have to download it out, or if you're going to do a process on it on the Science Cloud. You have to keep in mind what level of imagery you're using. So this is level 1B, so you need to make sure that 1B is sufficient for what you need to do. Otherwise, you might have to consider doing some orthorectification on it, which you can do on the Science Cloud. There's some Topology Spatial Center tools out there that you can use to correct the imagery if you need to. So you can contact me about that, and we can talk about it separately. So that's what I wanted to show you with this. The multispectral data is available as well, and this is the easiest time I've had getting to the imagery and looking at it on the Science Cloud, which is nice. Let me go back to our presentation, and we'll let Jim talk a little bit about what with Esri on the Science Cloud. All right. Did our demo. So before we jump in and you start looking at the slides, so one of the things we're trying to do with the Science Cloud is not only make it accessible using the Linux virtual machines, but we're also trying to incorporate more in the way of web services and other content. And one of the things that what we're using is ArcGIS. And so Esri products on the Science Cloud, and Jim has joined the team recently over the summer to help us figure out how we can incorporate some of these other technologies into the Science Cloud. We're trying to create a much larger project space with shared data sets that you could sign into and pan around on and use for planning purposes. And so Jim's going to talk a little bit about what that system is going to look like and when it might be ready, and I think he's got a little demo he's going to give as well. So Jim, if you want to go ahead. And you should be
Yeah,
able to
sure. Can
actually
everyone
advance
hear me?
slides too. Yeah, we can hear you.
Okay, great. All right. Just so everyone knows, we're looking at two systems. One that's going to be a public portal and one that's going to be an internal adapt-only private enterprise GIS. Each of those is going to go through a development phase. So altogether, we're looking at 5 phases if you throw in the project setup in there. But if we just initially focus here on the public portal, it's similar to what you can do on ArcGIS Online, except now we're going to have 100% control of it, and we being NASA and the ABoVE team are going to have full control over it, and we get a little more functionality when we have that extra control. The development environment was scheduled to be completed last Friday. We ran into a couple of glitches, but as you'll see today, we're really close. And the production environment, barring any roadblocks, should be ready on November 15th, but it does have to go through some security audits. It will be public facing. The private EGIS, that'll be 100% in the ADAPT environment. It'll be tightly coupled with the Windows desktop tools that you just saw that Liz presented. And that one we're looking at the end of the calendar year for the development environment and full rollout to production by middle of February. All right, next slide, please.
All right.
So just to give you guys an idea, Esri recommends a 3-tier architecture, one being the web tier, which is Portal, which you probably are all at some level familiar with, either ArcGIS Online or a Portal implementation. And then the applications are powered by ArcGIS Server, and then we have various data sources on the back end. So the key here and the main kind of takeaway from this slide is that all that data that Liz just showed you, our systems are going to have access to it at some level. So when data gets added to the file system, you'll be able to get to it both through the desktop side and through this infrastructure. Next slide, please. So any techies out there, this is kind of what the public portal is going to look like. It's going to have 2 servers that are communicating together. All of the Esri pieces will be installed on both servers. So we're not going to have, one server for just Portal, one server for ArcGIS Server, et cetera. Here we've got some redundancy built in and some load balancing capabilities that should help increase both reliability, uptime, and performance. Next slide, please. And this one is just to kind of give you an idea of what the internal one's going to look like. Yes, I know it's busy, it's some eye candy, it's complicated, but just want you to know that you're going to have a whole lot of power on the back end to do a bunch of processing and mapping and querying of these data sets and things like that. One note is that you'll see on the the right-hand side, the NGA data will have a separate security model. It will leverage the existing security model that you already adhere to, but it's going to be kind of in its own little enclave, kind of isolated away from the rest of the mapping services because there are additional restrictions associated with NGA. And that's really all I want to say on that slide. So you can go to I don't think there are any more.
No, that's the end. So
okay.
Bottom line is, guys, don't
ahead.
worry too much about these big diagrams, but we've got a team that's in place that's really trying to make these new capabilities user-friendly for all of you, so that it will just be seamless and you'll be able to use it. And it's, it's a work in progress, but I think Jim's going to show a little demo of some capabilities that you'll have access to. So I think, Jim, you want me to share your screen?
Yeah, if you can let me share my screen, I can go through a couple of things and show some folks where we are.
Stop sharing.
It's working.
So you're a presenter, so I believe you should have an option there to share your screen.
Yeah, it's going through it right now. Just stand by 1 second. I have to get the ad in, I think. Of course, we get technical glitches with the ad in. It's great.
While Jim gets that set up, is there anyone who has a quick question about what we've presented thus far? You can type it in the box or give a shout out and say it. What does the ADAPT environment mean, coming from Mark Chopping? So ADAPT stands for the Advanced Data Analytics Platform, and it is just it is the ABoVE Science Cloud, or I guess you could say the ABoVE Science Cloud is a portion of ADAPT. And apparently our Science Cloud is not a quote-unquote Science Cloud, so they've called the larger system ADAPT, or this analytics platform, and then our Science Cloud is a portion of that area. So if you hear ADAPT or you hear Science Cloud, for our purposes, it's almost synonymous. You can say you're working on ADAPT, or you can say you're working on the ABoVE Science Cloud. Jim, are you still working on your plugin?
Yeah, it's chugging along. Give it just about another minute.
All right, we have another quick question. Oh, Mark's coming up with another one. Oh, maybe not. Does this assume remote machines are running Windows? Is it still as slow as it was? You know, right now I'm working from home and I'm on my wireless network, and I've had a lot of success getting on the system this morning, even from home. It's been going pretty fast. Mark also said the X11 connection was slow when we tried to run Windows VM last year. I think it's faster now that we have Guacamole. I don't know, Ben, would you say that it's faster to access the Windows VM now than it was before?
Definitely in terms of loading, I mean, when you were in there trying to pull up imagery, I think those individual files showing up in your file system or in your browser, in your file browser, are definitely appearing much faster than they were when we were using Gluster.
Yeah, I think that the files will show up a little bit more quickly, and also I've found with Guacamole it's a lot easier to access the Windows VM, so I think that everyone should definitely check it out. I think it's a lot easier to use now.
Yeah, I think between moving from Gluster and then moving into the new ADC domain, it's definitely set things up faster than things were about a year ago.
Yeah. All right, Jim, we can see your screen now.
All right, good. Sorry for the delay on that. So you guys are all looking at this wonderful triangle here?
Yes.
Okay, great. All right, so so here's the idea behind Portal, just in case people aren't familiar, so we're all on the same page. So it starts with all the data, as I mentioned before. From the data, you make map services. From the map services, you can either take one or many map services and load them into a series of web maps. And then those web maps can be bundled into applications. So that might just be, you know, kind of reiterating something you already know, but let's go show you what that means in Portal. All right, so this again is under development, but you can see here this is kind of the portal that we have so far. So if I go to, just Liz, holler out if my screen display goes out or something like that. So anyway, if I go to my content, this is some data that I've already actually loaded into the system, and then I've kind of built upon it. So just to show you, there's a capability to actually upload shapefiles. So I grabbed some shapefiles that Julian had for the footprints data that you were just looking at that Liz was showing you. So here I uploaded this shapefile, and from this shapefile, it actually loaded it and created a service out of it, right? And so now I have a layer. That layer was then loaded into a web map, and then let's see what all that looks like, right? So if I go into, I've already brought up a couple of these ahead of time to save a little bit of time. This is the 2009, and we can see where all of our tiles are. If I just zoom into an area, they should pop on in, and just like Liz was doing, I can get the basic information, But this is actually something that I thought was pretty cool. I haven't done anything special to this other than loading the shapefile and creating a service. But because that shapefile actually has information about the raw image, I can go straight to this preview URL, and it'll bounce me out to Digital Globe and show me the tile. So I didn't have to go into Adapt to get the tile. It just gave me, a little bit of information that I could readily, use to find the source image, just to get kind of a quick thumbnail peek at it, right? And I can do that, with any of these that are out here. And it has all the necessary information. So this is a web map, which really doesn't have a whole lot. I can change symbologies. I can do things like that. I can set this pop-up so that maybe I hide some of this information that is, kind of redundant or not necessary for this particular web map. But that's about all I can do here. So I have this web map for 2009, and then I made one for 2010. So let's see what an application looks like. So what I did was I took the 29 and the 2010, and I loaded the web maps into this application, and I can quickly swipe and see where data was collected in either given year. So if I'm going in on an area of interest, I can see what years were, that data was collected. So if I wanted to get something in this area right here by the Niger River, then I would probably be looking at the 2010 data set. And then again, I can go and I can just go straight to that more info and get to the actual tile. That did not take a whole long time to put together, but the main point about it was just to kind of show you guys what some of the possibilities were from the web side of it. Again, this is in development. You can see it's just using one of my VMs out in Adapt or in the Science Cloud. So essentially this will be made accessible through a REST endpoint that you can get to from the internet. Now, caveat, if it's NGA imagery, you're not going to be able to get the NGA imagery from the public internet, right? Because the NGA imagery has to stay in Adapt. There are certain circumstances where it can come out of there, but that's beyond this discussion, right? But the point is that you will be able to see, you'll be able to quickly use the web tools to get to this data. So let's just take a look at what it looks like from a REST endpoint. So this one is actually available for anyone that's on NASA, and again, because it's in development, it's going to go up and down, right, until we release it to production. But in the meantime, you're welcome to kind of poke around with it. There's a sample world cities that's out here as well, where I can go and I can get a list of all of the cities that they have in there for that test layer. But let's do a real test here. So if I look at my 2009, let's go get some information from one of these tiles here. So now I've got I can get my strip ID out of this 2009 data set. And what I can do is I can come into this service. This is actually the same exact service that is powering this web map over here, or this application. And I can just use the REST endpoint to go get my information, and it'll bring back all of the pieces that are in that strip. Now, that looks great, but that doesn't really do me a whole lot. What if I'm a developer, or one of my developers needs to get to this? And I know that Liz and I have talked about this capability for some of the folks that are doing development for her. Stand by one second, I just need a typo there. So what we can do is we can either bring it back in this HTML format, which is just good for visual, but what if we want to do in JSON format? We can go and get all of the information about all of those tiles in that strip, right? All of these guys, this is their data right here. But then what if we don't want JSON? We want GeoJSON because our application is better with GeoJSON. Hang on, it's a long URL string. Let's see if I can do it this way. There we go. Now I'm getting the same data about those tiles in GeoJSON format. One note, just for people who are looking at this data, online or in various Esri applications, there's this little piece right here that says exceeded transfer limit. By default, every Esri web map service or ArcGIS server service will limit the number of tiles or responses back that can come back, to 1,000 records. So we can tweak that, we can change it, but the reason they do that is that if you're looking at a map like this and you have, let's say, 100,000 tiles, it's going to take so long for that 100,000 tile GeoJSON or JSON response to get back to you that you may tire of boredom and you may move on to other things. So we're going to have to find, the good number between the default of 1,000 response records to, what is usable for your guys' workflow to make sure that we're meeting your business requirements and at the same time not having you wait too long on the data to come back. And Liz, I think that's really all that I wanted to show. I just wanted to kind of show the soup to nuts on how it gets published and then how it can be accessed in the application as well.
All right, sounds good. Thanks, Jim. Well, we've got about 15 minutes left, and so I think with that, we'll go ahead and just take questions from people. If you're trying to use the Science Cloud and you're confused about something, you can let me know, and I will. We've got a number of people on the line that can help to answer that. So you can either type something in or just go ahead and shout it out. Maybe back to my. There we go. We can all look at Denali while we do this. Can't see my chat box anymore. Where did it go? Here we are. Okay, this is another one from Mark Chopping. All the NGA imagery is mapped onto a geographic grid. This can interfere with shapes of features. No way to get imagery in UTM or some other equal area projection. You could you'd have to switch it yourself to you'd have to switch the imagery to another projection yourself if you wanted to use it that way. Yeah, right now on the ABoVE Science Cloud, we don't have plans to alter the imagery to the ABoVE gridding or anything like that. But we are switching the Landsat data into the ABoVE grid and projection, so it's all in Canada Albers equal area for Landsat, but we're not doing that for the NGA volume. It's we're letting that stay as it is. All right, and Mary Ellen has a good question. Will a similar process work for viewing Landsat data stored on the ABoVE cloud? Yes, it will, and actually that's one of our plans as well, is we will probably take the Landsat the Landsat imagery we have on the Science Cloud, and we can put it into an imagery mosaic as well and do a footprint file of that, so you can see, you could pan around with that imagery too. That's one of the things we'd like to work on. Those mosaics, we won't be able to do them until probably spring of next year due to some Windows server and licensing issues, but that is something that we're going to do as well. Yeah, good question, Mary Ellen. Looks like a couple more questions. If there's time today, could you please show the Landsat directory? Yes, I will go ahead and show you the Landsat directory. Let's see, where is my, okay, so this is back to my, I can show you here. So this is in my Windows VM. You could see where it's located. If you go to, let's see, you could connect to a folder. Or actually, you could get to it from here too, from this file system as well. You would go to, it's under the Windows VM. It's here under Landsat, and you've just got the data in there. We have an ABoVE scientist, Damien Sulemanesh, is working to switch all the Landsat data into the ABoVE grid that we have for ABoVE, but then it's also available as is. That's the surface reflectance product for each of the 4, 5, 7, and 8, and you can go in, and I think it's half row and get it out. You could also do this on the Science Cloud itself. You could search for it too. So I can log into my my Science Cloud. So you can start a local terminal. This is with MOBA extern. This is what I like to use. Let's see if I can make that a little larger. And then you type in, let's see, nga login nccs.nasa.gov. Oh no, I think I have to do, there we go, SSH -X, capital X, and then I do ehoy at ngalogin.nccs.nasa.gov. And then again, this is your passcode, so this is your RSA token and PIN. Then you have to put in your password for the Science Cloud. Sorry that there are two things to do there. And so then here you can see there's a lot of useful information about where things are located on the Science Cloud. So if you kind of read this welcome message, I don't know if you guys can see that. I can make it a little bit bigger there. So we have large public data sets are available on user VMs by way of ATT pub repo. So you can do pub repo Landsat or pub repo Mara. So I'm going to do CD. I think you can get to the Landsat one from here, but if we can't, we can find out. Repo. So then I'm in the Landsat drive, and I could do ls, and you can see it's the same thing we looked at on the Windows side. So, and then you could do, cd, edc, espa, and now you're inside of that, and you could list it all out and see you have the Landsat 8, 7, 4, and 5 in there as well. Steve, does that answer your question about where that data is? Okay. And other questions? Who plans on using the Science Cloud for something coming up? I mean, are there more data sets that you guys want added into the Science Cloud? I could show you where some of the data sets are located right now on the Science Cloud too. That's always kind of a helpful thing. Let me see here. Okay. Let's see. Let's look at it. Let's look over here. What's my other schedule? Oh, here we've got another one. All right, Mark asks, can students working on ABoVE projects be authorized to access NGA data, or can they only use the ArcMap Digital Globe catalog to find and browse scenes? No, so let me put it this way. Let me go back to here. So this is our ABoVE Science Cloud setup and access. We have a handy chart which is actually being updated, but this is pretty close to what we've got. So if you're a U.S. citizen or U.S. legal permanent resident, such as if you have a green card, you can then request access to the ABoVE Science Cloud, and assuming NASA approves that, you could be granted access to the Science Cloud, whereby you could access public data sets on the Science Cloud, any of the Digital Globe data on the Science Cloud, and you could also you could request access for the Enhanced View web hosting service, which is the web browsing service set up by Digital Globe. If you're a foreign national, you have you're not allowed to request access to this Enhanced View site, but you can request access for the Digital Globe imagery on the Science Cloud and for any public data sets such as Landsat data. And if you're from a designated country, and there's a list of countries which are designated countries, if you're from that country and you don't have some kind of U.S. legal permanent resident status, then you can access public data sets on the ABoVE Science Cloud. You can request to access these data sets, and then, if possible, the access could be granted to you, but not the other two forms of data. So you can request access. If you want to access the Digital Globe data, you've got to be clear about what NASA ABoVE funded project or product you plan on producing with that NGA data. So that's one way it really needs to be tied to the creation of some data product for NASA ABoVE. Okay, and I've got another question from Steve. What is the benefit of mobile extern versus the ARC catalog? Oh, in terms of looking at the Landsat scenes, in terms of processing Landsat scenes using Python or GDAL. To process a lot of scenes, you would probably want to use the Linux VM and the like mobile extern or some other client to access the imagery and run a process on it. The Windows machine I find is very good for data visualization, and maybe if you have to process something in ArcMap, you would need to use the Windows VM. But if you plan on processing using Python or GDAL, then I would suggest you're going to want to use something like MobaXterm. This is the one that we've found seems to really work the best. And Mark Carroll, who works with us on the ABoVE Science Cloud, he is a pro at running Landsat code on the ABoVE Science Cloud. So Steve, if you have a particular project in mind, I can put you in touch with Mark. He couldn't be on the webinar today. He's usually on these. And he could help you start thinking about how to get set up on the Science Cloud and processing data. And all products that are produced with the Science Cloud should be a NASA ABoVE product that you plan on contributing to NASA ABoVE as one of the projects. Just a note that we try to make sure people understand that when you're using the ABoVE Science Cloud, it should be for a NASA ABoVE product. Yeah, Mark Chopping is mentioning he's run numerous jobs under Linux, the Linux side of the ABoVE Science Cloud, and Steve, you can contact him as well.
Speaking of jobs running under Linux, it is probably worth mentioning, even though we don't have a slide, that Slurm has recently been introduced into the ADAPT and Science Cloud environment. So if you might find that tool useful, feel free to send an email to support at NCCS, or we're probably just going to be rolling it out by default within the next week. We do have Slurm is it's a more industrial strength job scheduler. It's it has a formal queue, and you can see what jobs you have invoked out there. It's not unlike PBS if you've used any Linux job schedulers before. I see that you're typing, so I'm following on. Okay.
All right, I think I've answered all the questions that have shown up so far. Does anyone else have any other questions? If not, we're getting close to our 1 hour mark. So if you have questions or you want to follow up with a question afterwards, you can always send me an email and I can help you get it directed somewhere. But we have some space on the Science Cloud now for people to do some processing. So if you want to do some processing, now's the time to get on the Science Cloud and get it started. And if you're not exactly sure how to get it started or how to port your code over there, Mark Carroll in our office can help with that too. So you can email me or we can email him and get you started. We don't want to have everybody trying to access the Science Cloud all at once because we only have so many virtual machines. And same goes with the Windows virtual machines. They have a number of virtual machines that all of us that have accounts are spread out over. So if you're just doing something small, probably the virtual machine that you're set up on right now is going to be fine, if you're just trying to look at some imagery. But if you really need to use the Windows virtual machine to do some heavy processing of imagery, if you have to use ArcMap for some part of your process and you've got to use the virtual machine to do that, then you might want to contact us so we can give you kind of a different virtual machine space so that your process won't get interrupted and it won't be interfering with other people using the Windows VM. So this is kind of a very dynamic system which we can move things around on, and we always need your input. So please always let us know if there's something that you need. And without seeing other questions, we're at the 1 hour mark, so I think we'll go ahead and close it down, I guess, and we will continue next month. So let's see, that would be November 18th at 1 p.m. Eastern Time, which is right before the Thanksgiving holiday. So it's the week before the Thanksgiving holiday, so that works out well. So we will have one in November, probably in December. I think we will not have a Science Club webinar in December because it's the same time as AGU, and we don't want to conflict with that. So if you have something else, come back in November, and then we'll take December off probably. All right. Thank you guys very much for attending today, and if you have other questions, please feel free to let me know. All right, thanks everybody.
Thank you.